All right, today we've got a fun lesson planned. We're going to be looking at notes 5-2, converting from standard to vertex form using this new formula that we're kind of going to derive today. So where does this formula come from and what does it mean? We're going to talk about that momentarily. So you should recall that the standard form of a quadratic function is as follows: y equals ax squared plus bx plus c. And up until now, the method that we have used to convert from standard form to vertex form is the method called completing the square, the two notes that I've got directly above this set of notes. So after completing the square, it should follow, you may have noticed this pattern, that the x-coordinate of the vertex will always be, so the x-coordinate of the vertex, what is it always? What does it have in common with the standard form? So we're going to talk about that. Look up at your notes, 5-7, the very top of this page. If you notice, this was the standard form, and this was the vertex form when we converted it. So notice the difference between what is always going to be here. This number here is always going to be what? Okay, so look at this number, the x value of the vertex is always going to be what? What does it have in common with the standard form? So looking here at both of these two, hopefully you notice that when you created this perfect square trinomial, the number that's always going to go here is always half of this number. Okay, so my x value of my vertex would be opposite of that, comma, well, we know what the y value is, but opposite of that, and where does this number come from? Well, it always comes from half of this. So let's verify that here. So here, the number here came from half of -8. And so therefore, when I found my vertex, the only thing I did was change the sign. Okay, so it's -4 here, so it'd become +4 here. All right, so let's look at it when we had a number, a value that was not equal to 1. So on this type here, notice this number still came from half of this number. Do you agree? So there and then here, this number is half of -2. So, but if I'm looking for a formula that starts way back up at the top when I was given the standard form, okay, so in this case, because the a value was 1, you can still look at that b value and say, okay, my x value of my vertex is always going to be half of this number, but change the sign. So half of 6 is 3, but I had to change the sign. And similarly here, half of -8 was -4, excuse me, but change the sign to make it +4. But it's a little different when the a value in front is not 1. So here, before I even started the completing the square, I had to factor out whatever a was. Okay, so on this one, I factored out 3 from all the terms. Oh, well, except for the 1, because we leave it on the outside. So what happens here is this number derives from this number divided by a. So 24 divided by 3 is 8. And then half of that is where we get this number. And then, remember to find the vertex, you take the opposite. So, in this case, if I'm looking back up the original, how I got this number was I divided this by a, correct? And then, so that would be 8. 24 divided by 3 is 8. And then I halved it, so half of 8 would be 4. And then I just took the opposite sign. Okay, so let's look and see if that works here. So if I look back at my original, and so my vertex for this, let's get that first, would be +1, -3. Okay, so here, if I take this number, I divide it by -6, that would be -2. Half of -2 is -1, and then change the sign. So the formula for the x value of the vertex is always going to be this number divided by a, also halved, and then opposite sign. So that's where we get this. So the x-coordinate of the vertex will always be opposite of b, remember, because we had to change the sign, okay, divided by 2a. Because you take that number, you divide it by 2, and you divide it by this. You divide it by both. So this is kind of the compressed formula of that. So here, the y value of the vertex will be f of negative b over 2a. Sorry, my 2's and a's look a lot alike. So that's a 2 and that's an a. Okay, so what does that mean? That means you're going to plug in the x value of the vertex into the equation, and that's going to give you your y value. So we're going to do an example. Recall that the y-intercept of this function, because this is something we're going to have to use to graph, is at the coordinate 0, c when the graph is in standard form. So right away, let's do that first. We can see this quadratic is in standard form, and the y-intercept will be the coordinate 0, 3. Because if I plug in 0 for x, those are both going to go away, and the only thing that's left is 3. So I know my y-intercept is at 1, 2, 3. That's something I can gather. Now, to graph this, I need more than just one point, right? I need a lot more going on. So the easiest way is to find the vertex. And so you know how to find the vertex using completing the square, but now we're going to use the formula that we just got from completing the square, and you may end up liking this a little bit more than actually completing the square. So based on our formula here, the x-coordinate of the vertex is going to be opposite of b divided by 2a. So that means the x value equals opposite of b, so negative 2, that's b, divided by 2 times a. Well, a in this instance is 1. So that's going to be negative 2 over 2, which is actually going to be negative 1. So that's our x value. So for the vertex, we know it's negative 2, something. How do I find the something? So that's what I was explaining here. If you take that x value and you plug it in where you see x, that will give us our y, correct? So we've got y equals, x is negative 1, so negative 1 squared plus 2 times, again, plugging in negative 1 where I see x, plus 3. So what is negative 1 squared? Negative 1 squared is 1, and then this is minus 2 and plus 3. So 1 minus 2 plus 3 would equal 2. So my y value of the vertex is 2. So I can plot negative 1, positive 2. If that's my vertex and that's another point, because I know that where the vertex is the axis of symmetry, right here, it follows that there must be another point right here because it's symmetric. So that means, again, another thing that kind of follows, if I'm climbing from the vertex right one up one, this must be just the standard 1, 2, 1, 2, 3, 4, excuse me, I'm counting and trying to talk, the standard points for a quadratic, because a must be 1, and we already know that anyway. Looking over here, a is 1. So this is my graph of the quadratic. I don't know, what do you think? Was that better than completing the square? It's just a different method that you can use. You know, it's always nice to have more than one method to do one thing.